Hello and welcome back to my RC channel. I'm Andy RC, and today I'm going to be doing some thrust testing on various configurations for micro-sized quadcopters. So what gave me the idea for this is actually a problem that I've been having with my Alien Wii board. It's been randomly rebooting and resetting everything to the default settings. Now, I went onto the custom micro quadcopter Facebook page and they advised me that it was doing that because I was letting the battery go too low. But I'm always very careful with my battery, and I've never had this so that the motors aren't running and the battery's completely flat. I always set a timer, so I don't know what's going on with that. Anyways, what I have found is when it resets to its default settings, it's only got one of the flight modes on the switch, and that is angle mode. It doesn't have horizon mode set up. So when the switch is in the other position, there's no modes, which means that it gives a complete acro mode. There is no self-leveling going on, and no matter what angle you put in, it carries on going. So if you have it upside down, it carries on going down until it crashes to the ground. It never rights itself. That is interesting in itself because it's really nice to fly with. It's definitely different than flying with the auto level, but that's a different subject. The reason why that is good for thrust testing is I can flip it upside down here and place it on some scales and then lift the throttle up, and it's going to push down into the scales, and that's going to give us the thrust reading in grams for all four of the motors working together. Now, I know some of you will be saying, well, actually, you could just keep the flight controller in its level mode and flip the motors round. But yeah, I don't want to mess around with the motors, and you'll see why that is later. I've got a great way of putting all this on the scales. Now, I know some of you may be thinking as well, why don't I switch the props so the direction changes and it pushes the quad into the ground rather than lifting up? I did think of that, and I did try that, and it doesn't work. The props are not as efficient at blowing air that way than they are that way. And so it gives a false reading if you do that. So let's talk about the variables. These are the stock Hubsan motors. So I've also got the Dark Edition motors from Micro Motor Warehouse. So that is the first variable. Second variable is the battery types. We have the 25C 500 milliamp batteries that everyone is used to using on the Hubsan model. But also we have the Nanotech 750 milliamp battery, and it's 35C to 70C. So we've got more thrust variables there. The next variable is, of course, the propellers. We've got the rolling spider props here and here. We've got the YD717 propellers here. We've got the Hubsan clear props there and the Hubsan normal props there. And we've got the Ladybird propellers as well. Now, I know there are other propellers on the market. There are a lot of other propellers. Some of them are variables of this. We've got the 3-leaf props as well. Those are absolutely rubbish. I'm just testing props here that I think are contenders for thrust testing. So that's what I'm going to do here. So this is what I'm going to use for the test. I'm using my friend's frame, Phil, who provided this to me. It is long enough for all of the props to clear this roll of tape here. So this is upside down. It's not got any auto leveling. It's going to give us the full thrust, so we're going to get a fairly accurate reading. I'm going to take the batteries. They're going to get banded underneath there, and I'm going to throttle up, and this is going to give me the thrust reading here in grams. Now, before anyone asks, I know that I could connect a multimeter and we could get the amp draw and things like that. I'm not really interested in that. I understand that if we're going to get more thrust out of the motors and the propellers, it's going to draw more from the battery and your flight time is going to be less. This is purely just to measure the thrust of the different motors, the different batteries, and the different propellers. I want to set a couple of things straight before we start the tests. All motors are 8mm. The flight controller to be used is the Alien Wii board. Each test combination had its own battery charged to 4 volts. From the moment a quadcopter was plugged in, it no longer has a full battery. That was my reasoning for this. Each test was ran 3 times and the average result will be used. The tests were done over a period of days and motors were allowed to be cooled before the next test was completed to give fair results. Motors were not thrust tested individually as this appeared to give false readings. I think this was due to the fact there were no other motors drawing from the power source, so we're giving higher readings than if all 4 motors were connected. Instead, all motors are ran at the same time and the overall thrust will be divided by 4 to give an average single motor thrust. The peak thrust in grams will be recorded. The throttle will be lifted gradually because punching the throttle creates inertia, and this produces a higher thrust than the motors can sustain. I will show clips of the test and after I will analyze the results. The clear hubs and props on hubs and motors showed little difference in thrust between batteries. Same on the Dark Edition motors, although 123 grams is much more overall. Stock hubs and props and motors showed a lot more thrust on the 750 mAh battery than the 500 mAh battery, over 10 grams. Same with the Dark Edition motors, 6 grams more thrust just on the battery change. I think this is down to the extra stiffness on the stock props compared to the more durable clear props, but they are losing thrust higher up. The YD717 props produce more thrust than the hubs and props, but only by 4 grams on the 500 mAh battery, and a noticeable lower RPM than all the other props. However, it pulled 100 grams on the 750 mAh battery. These props break really easily though because of the stiffer material used. On Dark Edition motors, however, they scored less thrust than the stock hubs and props, which was a surprise, and hardly any difference between the two batteries. Ladybird props were a disappointment all round, and same goes in practical use. Very low thrust with both batteries on hubs and motors, and also the lowest thrust results on both sets of motors. On Dark Edition motors, the Ladybird propellers performed worse than the Rolling Spider props did on hubs and motors. Rolling Spider props generate the most thrust on the hubs and motors. However, the YD717 props were not that far behind at this point. Surprisingly, switching to a 750 mAh battery gave a lower result than the 500 mAh battery, but not by much. Dark Edition motors and Rolling Spider props gave the biggest thrust reading on both batteries, with 140 grams on the 750 mAh nanotech battery, which is 35 grams per motor, which is almost the weight of 4 Mobius. The highest thrust props on the hubs and motors is without a doubt the rolling spider props, either with a 500 mAh battery or a 750 mAh battery. However, I have mentioned in previous videos that I bought 3 sets of these and I was only able to make up one decent set due to vibration issues. I can physically see them vibrating over half throttle, and some of the hubs are not in the center. We need a decent way to balance these micro props. I have never had a problem with vibrations on stock hubs and props, however, apart from when they are severely damaged. I can't recommend the YD717 props because of their durability. One crash and the props are snapped, which is a problem flying in tight spaces. As for Dark Edition motors, the rolling spider props give insane thrust, but the motors are almost too hot to touch within seconds. I will test these motors to see how long they will last, but my guess is not very long. Until then, I recommend the stock hubs and props with the 750 mAh Nanotech battery with Dark Edition motors. 32 grams of thrust per motor and 128 grams in total is more than the rolling spider props can perform with the hubs and motors. Durability of the Dark Edition motors is still in question, however. A couple of things to note: the peak thrust of the motor is not an indication of what throttle percentage the quad will hover at. For example, in this test, 50% throttle gave 71 grams of thrust, 100% throttle gave 105 grams of thrust. Divide that by 2 and you only get 52 grams at 50% throttle and not 71 grams. It's fair to say that there is definitely a tail-off in thrust with these motors, and generally they are not designed to be used on full throttle. In general, apart from the Ladybird propellers, most combinations will hover around 50 to 60% while pulling this 66.8 gram quadcopter. Something I found really funny is that with the rolling spider props and Dark Edition motors, the quad would lift the entire roll of tape that it was banded to at about 60% throttle. So I hope this video helps you decide what combination to use with your Microquad. Thanks ever so much for watching. I hope you enjoyed the video. Please continue to subscribe. Cheers.